Hello viewers, in today's class we are going to discuss one important concept in three-dimensional geometry, right? So here we'll discuss the intersecting lines, right? So here we are given a problem that show that the lines intersect and hence find the point of intersection, right? So in three-dimensional geometry we have the equation of these two lines, say L1 and L2, right? And this is line say L1, and let us take this line as L2, right? And here we have to show that these two lines intersect, and we have to find the point of intersection of L1 and L2, right? So let us take this point P as the point of intersection, right? So now what we will do, the concept is to find out the coordinates of the general point on the lines L1 and L2, right? And how we find the coordinates of general point on a line. What we do, we take this as lambda, and here we can take as mu, right? So in the equation of the line, we equate all these ratios equal to lambda. Similarly here we take mu, and lambda and mu are some scalars, right? So now if we take this line L1, then we see that x minus 4 over 1 is equal to lambda. Then we have y plus 3 over minus 4 is equal to lambda, and z plus 1 over 7 is equal to lambda, right? So lambda is a scalar, right? So now from here we see that the value of x is lambda plus 4, and from here the value of y is minus 4 lambda minus 3, and from here z is equal to 7 lambda minus 1, right? So we have obtained the values of x, y and z in terms of lambda, where lambda is some scalar. So now the coordinates of the general point, the coordinates of the general point on line L1 is given by lambda plus 4, minus 4 lambda minus 3, and 7 lambda minus 1, right? Okay, now the same process will be taken for this line L2, right? So now we see that the coordinates of the general point on this line L2 are given by x minus 1 over 2 is equal to mu, then y plus 1 over minus 3 is equal to mu, and z plus 10 over 8 is equal to mu, right? And from here we see that x is 2 mu plus 1, and y is minus 3 mu minus 1, and z is equal to 8 mu minus 10, right? So now from here we see that the coordinates of the general point, any general point lying on line L2 are given by 2 mu plus 1, minus 3 mu minus 1, and 8 mu minus 10, right? So now we have obtained the coordinates of the general point on line L1 and general point on line L2, right? Now if these two lines intersect, right? If these two lines intersect, then there is a common point between L1 and L2, right? And for that common point, these two coordinates must coincide for some value of lambda and mu, right? If these two lines, if L1 and L2 to intersect, right? If these two lines are to intersect, then there must be some value of lambda and mu for which these two coordinates should coincide, or in other words we can say that these two coordinates should be equal to each other, right? So it implies that lambda plus 4 should be equal to 2 mu plus 1. That is, the x coordinate should be equal, y coordinates should be equal, and the z coordinates should also be equal, right? So what we have explained just now, that in order to these lines to intersect, there must be some value of lambda and mu for which these two coordinates should be equal. It means the x coordinates, y coordinates and z coordinates should be equal to each other. So now we have here three equations in lambda and mu, right? So now viewers, here what we will do, we have two variables here, lambda and mu, but we have three equations. So what we will do, we will solve any two equations, right? And we'll find the value of lambda and mu, and then we'll substitute that value of lambda and mu in the third equation, and if that equation is satisfied, then we say that the two lines intersect, right? So let us first rewrite these three equations or simplify these equations. So we have lambda minus 2 mu is equal to minus 3, taking 4 to this side. Then we have minus 4 lambda plus 3 mu is equal to 2, and here we have 7 lambda minus 8 mu is equal to minus 9, right? So now we have 4, 5 and 6, right? So now here we have three linear equations in two variables. Now we can solve any two equations, right? So it is up to us to select the equations. So here I am taking equation number 4 and equation number 5, right? And we'll find the value of lambda and mu from these two equations. So we have already learned that how to solve linear equation in two variables. So what we will do, we'll multiply this equation by say 4, right? So 4 lambda minus 8 mu is equal to minus 12. So what we will do, we'll multiply it by 4. So we have 4 lambda minus 8 mu minus 12, and we'll take this equation number 5 as such, right? And what we will do, we'll use the elimination method, and now we'll add these two equations. So these two get cancelled. Here we have minus 5 mu, and here we have minus 10, and mu is equal to 2, right? So the value of mu is equal to 2, and we can substitute mu equal to 2 here. So we have lambda minus 2 times 2 is equal to minus 3, and we have lambda is equal to minus 3 plus 4, that is 1, right? So the value of lambda is equal to 1. So viewers, we have obtained the value of lambda and mu by solving equation number 4 and 5. Now we'll substitute these two values in equation number 6, and if the equation number 6 is satisfied, then we can say that these two lines intersect. And if the sixth equation, the equation number 6, is not satisfied by these two values, then we say that these two lines do not intersect, right? So let us substitute here lambda equal to 1 and mu is equal to 2. So we have 7 times 1, then we have minus 8 times 2, and here we have minus 9, right? So we have 7 minus 8 to the 16, and here we have minus 9. So 7 minus 16 is minus 9, and here also we have minus 9, right? So we conclude that these two values also satisfy equation number 6, and hence finally we can say that these two lines intersect. And now we have to find the point of intersection. Now the point of intersection P can be obtained by substituting lambda is equal to 1 either here or the value of mu over here. So we'll take this one. So we have the point of intersection as 1 plus 4, then we have minus 4 times 1 minus 3, then we have 7 times 1 minus 1. So 4 plus 1 5, and this is minus 4 minus 3 minus 7, and this is 7 minus 1 6. So these are the coordinates of the point of intersection of these two lines L1 and L2, right? And if we substitute mu is equal to 2 over here, then also we'll get the same result. Let us see how. So we have 2 times 2 plus 1, then we have minus 3 times 2 minus 1, and 8 times 2 minus 10, and this is 4 plus 1 5, this is minus 6 minus 1, that is minus 7, and here 8 to the 16 minus 10, that is 6. So these two coordinates are same, right? So this is how we solve the problem of intersecting lines in three-dimensional geometry, right? So what we do, we find the coordinates of general points on the two lines, then for some value of lambda and mu the two must coincide, and we get three equations in lambda and mu. Then we select any two equations in lambda and mu and we solve them as linear equations in two variables, and we get the value of lambda and mu. Then we'll substitute these values of lambda and mu in the third equation, right, which was the left out equation, and if that equation gets satisfied by these two values, then we claim that the given lines intersect, and the point of intersection can be obtained by taking lambda, the value of lambda over here, or the value of mu over here, right?